see about synchronization.
So basically, it's not about a critical section of a thread we are discussing about. We are discussing about a race condition of a race condition. What do you mean by race condition? So the two or more threads accessing the same resource and trying to access it or update it and trying to act on it, I can say. So then it's called as a race condition. How will deal with this race condition? We'll see an example and then we will talk about this. Okay. So now obviously we'll try to do a task. Okay. So what happens? We'll see. Critical section. So coming to the next slide, that is the race condition, as I told you, like we did increment of a function. What happens to the increment of a function? So how we will avoid this? How we'll avoid this problem, and how we will avoid this using locks. Using a locking mechanism, we can avoid this race condition. Like we will use the locking mechanism, so like synchronization. This locking mechanism will help us to lock the thread for a certain period of time. So then what happens once the action is done? What we will do? We will release the lock. We will release the lock. So with help of this, we can achieve a synchronization between the threads. So there should be a locking mechanism which helps us to do this kind of to address this kind of synchronization of threads. So let us see the example how we will do. We can see the example. So we need to write down a thread. So what we'll do, how to import a thread. Yeah. So we'll say import threading. I can say we can declare one variable that is called x. Okay. So now we will define a method called increment. So which may be which will do some variable, like we'll define that value at global x, and x is equal to x plus 1. We'll say x is equal to x plus 1. We are incrementing the value. Why? Because the x value should be globally affected. So that's the task. And we'll define a thread task. We'll define a thread task which will do a task for us. So which will task in thread. This is a task in thread. What it does is it will call my increment function for a range in of I can say the range is for now it is let's consider some number, any number it can be, and it will call my function. What happens? We will create a number of threads of this particular function. What will happen? So if so many functions are trying to increment the value. Okay. So what we'll do, we'll define the original task, which is actually doing, which is the main task, I can say, or original task, I can say, whatever it is. So some people will say this is like a common example which is available in all the internet. So we'll say global x. We'll say again global x, setting the global variable as 0. Okay. So now again x is equal to 0. We'll say. Now what we are going to do? We are going to start our threads. What is that? Creating a thread. What is that? T1 is equal to, how we'll create a thread? It is not user defined thread. So we saw already thread, and target is what? What is our target? What is our target? Thread task is our target. So because that is a thread task only we are defining, right? So thread task is my target. So T2 is also threading thread, and what is the target? Is same thread task. Okay, thread task is that one. Now what we need to do? We need to start, right? We need to join or we need to start? We need to start first. So without that starting, we can't join, right? T2 that start. and then we will say T1 dot join, T2 dot join. Okay. So now if this is a fine, if this is the case is fine, we'll see. So now we can write a main function also in that. If underscore name underscore is equal to a main function. So we'll say this, yeah, obviously it will happen, it will execute when nothing is there. Now what we need to do, we need to write a definition. So we'll call our original function I in range of what is that? We will say 100 or 10. Yeah, we can say 10 only. We'll say less on. I don't know how to do hundreds and all. What we need to do, we'll call original task. I'm creating so many threads now. So many threads we will call. So original task is being called, and I want to print the iterations. So what will say iteration? Okay, iteration of x is equal to, I can say, okay, what I want to do? Particularly I can print comma x, I can say. Okay, I and x I can say. So that is one I can say. Now what happened? Now we are calling the original task so many times because your thread will start. There is no sleep, so automatically all threads will access the increment function. So this is our increment function. So many times we are saying. So now we'll run this program. See here, what happened? If it is a less number, okay, if it is a less number, it is working fine. So it is printing this much, okay. And so final value is expected somewhere around 2 lakhs. So it came, okay. So now this happens like if you see here, there can be an unpredictable value also in this task. So what will happen in this task? If you see here is, if I increase the value to 100, let us consider. Okay, so I'll increase one more value. See here, actual value should be what? Its actual value should be somewhere around 20 lakhs. But 20 lakhs came? No, never. What happened? It is predicting somewhere only it is coming 20 lakhs, right? Somewhere only it is coming. So in between, it is like, what do you say? It went into a race condition only, right? Somewhere only it is coming. We didn't say sleep, right? So now you have 100 tasks, 100 original tasks, sorry. See, the value here is very unpredictable. Okay, the value here is unpredictable. Actual, how many it should be according to your point? It is incrementing the value one by one. Okay, it is incrementing the value one by one. How much it should be? It should have been around 20 lakhs. So, but where the 20 lakhs came? If you observe here, somewhere around, like, see here. Here only at 76 iteration it came. Right, we are accessing threads simultaneously, and this is called as critical section. The unpredictable values. Now, if you see, the expected final value is 20,000, but we get 10 iterations of main, like 10 iterations, 100 iterations of main task. Okay, 100 iterations of original task. This happens to the thread shared variable. We have shared a variable x between all the threads. This is unpredictable, nothing but a race condition. Okay, so now that's where the point is. Okay, this is very important point of view. You need to understand your iteration is this one, like 15th iteration or somewhere in 18th iteration you got the value as the global value is shared. Okay, as the global value is shared. So the point is here you need to understand. Okay, is you are getting the data not correct. So now what happened? What is happening here? The increment happened So in thread 1, it has read the value of integer 10. Okay, it has read the integer 10. So now what happened? Thread 2 also read. In between the increment operation happens. Okay, so both should be 11 and it should write 11. So now in meantime, the another thread has read. Another thread has read. But due to the race condition, what happens? The unpredicted values will come. Before completion, only 2 threads will access the another value. Another thread will access the previous value. So there is a no proper synchronization between a multiple threads. So using locks, we can do this mechanism of what do you say? What they're saying? Using locks, we can have a proper mechanism of synchronization is what they're saying. So now we'll save this race condition in thread. See, as we increment the number, what happened? It went into a race condition. In order to remove this race condition, we'll acquire synchronization using a lock mechanism. Okay. So, we'll say we'll acquire the lock. So how we will acquire the lock? Lock is okay. We'll see how we'll acquire the lock and what is that. We need to import this lock also, right? How we will import this is the first question. We need to pass a parameter called lock. Okay. In the main task, in our original task, we need to create a lock before to the thread creation. So that is threading dot lock. I say I locked the thread. Okay, I locked the thread, and I'll pass this as an arguments, and I'll pass this as an arguments to the function. So lock. The same I'll pass here also. Clear? Oh, okay, now that is done. So now what do we need to do? Our main task should have our original task, thread task should have a parameter called lock because it should get the lock, right? Should get the lock. And we say we'll acquire and we'll complete that, and then only we'll release this. Right? And then only we'll release this. Then what happens is what we are going to see. This is a simple change we are going to do here. Nothing otherwise big deal we are doing. Synchronization. Okay, synchronization of thread. So I can save it as synchronization of threading. Okay. So now what will happen? Multi-threading threading dot lock is not available. Okay, lock is a class. Okay, lock is a class. See here, from the iteration 1 itself, what happened? Until the iteration completes, the lock has been acquired, and then every other function will have the same value. Every other thread will have the same value. So you create a number of threads, you create a number of iterations, all will get the same value. Basically, if you don't acquire a lock, what will happen? It will go for a critical section. It will read unpredicted value. This is what happens in our transactions also. You have 100 values here. What happened? So it is taking a locking mechanism. It locked and it will give you what? A locked mechanism. Finally, the value output will be the expected value. So now it's like the increment will happen. It will acquire the lock. It will acquire the lock. The increment will happen, and the lock will release. So for every thread, this will happen. This brings us the advantages of it doesn't block the user. This is because the threads are independent of each other. they better use the system resources, and it is possible to us. Okay, and enhanced performance also. Like all threads starting at one time simultaneously, it's a dangerous for us. And multi-threaded servers and interactive GUI uses this multi-threading environment with locks. Without locks, you can't do. So if you don't use the locking mechanism, if the number of threads are increasing, what happens? The system will go into a rest condition. And synchronization is for sure is a necessary. Without the synchronization, you can't do anything. Okay, this is the actually a lot of people will copy this example. Actually, this is a very simple example we have in Python. So many people will do same functions. Basically, we took a lock thread. Rather than that, we should take a lock class. Threading.lock is a locking mechanism where you will send the lock for every thread. This is the main thing you need to do here. So wherever the function call is happening, or you can do this same in our increment method also. You can pass this to our increment method here. So that is also possible. Okay, fine. Hope you understood about the synchronization block. Any doubts still here? That's it about the threading mechanism we are going to discuss in Python. Okay, so that's what we had in the syllabus also. Like we have to discuss about the threads, joins, runs, and creating our own thread, and a synchronization block, and without synchronization block of race conditions also.